the next question, or the fifth question, is as follows. You have a cylindrical glass rod like this of mu 1.5. The diameter of both the ends are like hemisphere, and they have a diameter of 10 centimeter. An object is placed at this point at a distance of 20 centimeter from this end, and the image is obtained 40 centimeter at the other end. So this is the position of the image at a distance of 40 centimeter from the other end. So the question is, find the length of the glass rod. So in this question, you try this question on your own. This is the fifth question. In this question, it's only given that the object is placed 40 centimeter from the other end. So the image can be formed here, or the image can be formed here also at a distance of 40 centimeter on this side. So assuming that the image is formed here, let's assume that to be case 1. Let's solve that, and then we'll move on to the second case when the image is formed here. Now what formula do I use? I'll use the formula for refraction at spherical surfaces. The formula is this: 1 by u plus mu by v is equal to mu minus 1 by r. What is mu? Mu is mu refractive medium by mu incident medium. Okay, so the first refraction occurs here. So what is u? U is positive or negative? It's positive because I move from the object to the surface in this direction. The rays of light also move in this direction, so it is plus 20, plus mu is 1.5 because this has a mu of 1. V is equal to mu minus 1, that is 0.5. R is what? R is the radius of curvature. The diameter is 10, the radius is 5. So if you solve this, you will get V as 30 centimeter. So the image formed by this surface is somewhere here. Somewhere here. So this is my intermediate image. Now for this refraction, this becomes the object. So for the second refraction, this is my object. So what is this distance? This whole distance is L. This is 30. So this is L minus 30. And it is positive because I move from the object to the surface in this direction. The rays of light also move in this direction. So L minus 30 plus refractive index of this medium with respect to this medium. It's 1 by 1.5. So I can write it as 2 by 3. And what is V? V is positive for this case because V is formed here. The refracted rays also in this medium. This is equal to mu minus 1. What is mu of this medium with respect to this medium? 1 by 1.5 minus 1. And what is R? It's minus 5 in this case because R lies this side, the refractive rays in this side. This comes out to be 1 by 15. So now if you solve this, you will get L minus 30 as 20, or your L as 50 centimeter. So this was the first case when the image was formed 40 centimeter to the right of the surface. The second case is when the image is formed 40 centimeter to the left of the surface. Let's discuss that case. Now when the image is formed 40 centimeter to the left of the surface, what is u? U still remains L minus 30 plus mu by v. What is v now? V is negative. Why negative? Because this is my real space. V lies in this space. This is equal to, this remains the same, 1 by 15. Now if you solve this, you will get L minus 30 as 12 or L as 42 centimeter. So you have two answers, one is 50 centimeter and the other is 42 centimeter. Now we move on to the next question, that is the sixth question, before we wind up the topic of spherical surfaces. The next question is as follows. The next question, you have a cubical block like this. Okay. The refractive index of the glass of this medium is 1.5 and this has a side of 36 centimeter. Okay. Now you have a spherical cavity inside this cubical block. The spherical cavity is symmetric at the center and it has a radius of 9 centimeter. This has a radius of 9. So also 9. Since it's symmetric, this distance is also 9 and this distance is also 9. Now when object is placed 18 centimeter from one surface of the cube. So the object is placed here, this distance is 18 centimeter. So now the object is observed from this side and the question is find the apparent position of the object. Okay. So let's try this question. Now in this question, a common mistake what students do is that students assume this part to be a plano they assume this as a plano convex lens. Sorry, plano concave lens. Remember, when we talk of lenses, we only talk of thin lenses. That means the lenses won't have a thickness. So a plano concave lens looks like this, but this thickness is negligible. In this case, you have a thickness of 9 centimeter. So this is not, or the formula of lens is not applicable in this case. So in this case, we need to consider each surface and then we need to consider the refraction occurring at each surface. So this is my first surface, this is my second surface, this is my third surface, this is fourth surface. This is the third surface and this is the second surface because we have air inside it. So let's write what is u, what is mu, what is r and what is v for each of the four surfaces. Okay. For each of the surfaces, I'll use the same formula, that is 1 by u plus mu by v is equal to mu minus 1 by r. Okay. Now for this surface, what is u? U is plus 18. What is mu? Mu of refracted medium with respect to the first medium, it's 1.5. What is radius of curvature for this surface? It's infinity because it's a plane surface. If you solve this using this, you will get the v as minus 27. Minus 27 means the image is formed in this side. For this surface, this is my real space. The image is formed in the virtual space. So image is formed this side. So what is the image distance for, sorry, what is the object distance for this surface? It's minus 27, that is 27 plus 9. So that means 36. And this is a positive because same direction as the incident ray. What is mu of this medium with respect to this medium? It's 1 by 1.5 or 2 by 3. Refractive index, sorry, radius of curvature is positive. Now if you solve this, you will get v as minus 72 by 7. So my image is formed on this side again because it's negative. Now for this medium, what is my object distance? It's 72 by 7 plus 18. If you do this, you'll get it as 198 by 7. What is mu of this medium with respect to this medium is 1.5. Radius of curvature is negative because this is my real space, this is my virtual space. So it's minus 9. If you solve this, you'll get this as minus 33 by 2. I'm using this same formula again and again. Now for this surface, what is the object distance? It's minus 33 by 2. 33 by 2 plus 9. That means 51 by 2. What is mu? its refractive index of this medium with respect to this medium, it's 1 by 1.5. R is again infinity. If you solve this, you'll get this as minus 17. So that means the final image is formed 17 centimeter from this surface, somewhere here. This whole distance is 36. So this distance is 36 minus 17 or 19. So what is the distance between the image and the object? Is 18 plus 19, that is 37 centimeters. Okay, so I hope we are done with the topic of spherical surfaces. Now let's take one more topic, that is combination and silvering of lenses.